Okay, so this operational amplifier, this is the symbol we have done. This is positive supply. This is negative supply. This is output voltage terminal. This is non-inverted input voltage, and this is inverted input. So in operational amplifier, supply is voltage, input is voltage, and output is voltage. So all three are voltage, not current. Now suppose number one, if this terminal is connected with the earth, so this becomes 0, and direct voltage is supplied to this terminal, which is Vn. Then according to the formula, V out is equal to A naught difference of the input. So we can write A naught, and the difference of the input mean just the input, because something minus 0, it becomes the same number. So output voltage divided by input voltage is A naught, and this A naught is called gain, and it is also known as open loop gain. When the graph is plotted between input voltage and the output, both are directly proportional, so straight line passing through the region. But when this output voltage becomes equal to supply voltage, so operational amplifier becomes saturated, so no further gain. So the gradient of this graph is gain A naught, and after this input, it is saturated, no gain, so gain is 0. Number two, if this voltage is not direct voltage, it is alternating voltage, then the formula will remain same, but the graph will be different. Due to alternating voltage, we have to draw both side output, V out positive, V out negative. Now this is V in. Look, one of the input is 0, mean connected with the earth. So this is a non-inverted input which remains 0. And the other input is alternating. Suppose this is changing like a sine wave, and this input is inverted input, alternating. Now the graph for this will be different. So first of all, we will mark supply voltage positive and supply voltage negative both sides. And then we will draw bars, vertical bars, where both inputs are equal. So these are the points where two inputs are equal. So vertical bar at this point, and the height of the bar must be equal to the value of the supply. Then the next bar here, both sides equal to supply. So positive supply, negative supply, it is up, down, and up positive supply, down negative supply. So the height of the vertical bar, both sides equal to supply, positive, negative, but they are drawn exactly where both inputs are equal, okay? Now in this region, we have two inputs. One input is 0 and other is greater than 0. So this 0 is non-inverting and this non-zero is inverting. We have done when inverting input greater than non-inverting, then output polarity is negative. So when inverting greater than non-inverting, polarity is negative. So we will join these two bars in the negative portion. And here, this 0 is greater than this negative value. So V inverting is smaller than 0, means smaller than this non-inverting. So output will be positive. So positive output and then negative output, positive output, negative output, and so on. So this is the graph between output and input when one is connected with earth and other input connected with any alternating voltage. The maximum voltage equal to supply, and the shape of the output is not a sine wave, it is square wave. So do remember, from electronics, the output is always in the form of square wave. Okay, now number 3. This is suppose OpAmp, operational amplifier. Now this input is direct voltage, any value, not 0. And this inverting is alternating, suppose. Then the graph for output and input. So this is V out positive, V out negative. This is supply voltage. This is the supply voltage negative. Here Vn. Suppose one input is direct, which is constant, and the other input is fluctuating. And it is alternating voltage. Now we have to draw the output voltage. Again, same procedure. We will mark the points where both inputs are equal, not the 0 line, now the positive line. Okay. These are the points where both inputs are equal. So we will draw here vertical bars, but the height of the bar must be equal to supply both sides. Similarly here, next, so we have to draw a bar exactly at the equal voltage point. And the height, the size of the each bar must be equal to supply both sides, okay? So keep it listen. Now, for this small portion, this one, look, this non-inverting is greater than inverting, so the output is positive. So we'll join here positive, then this negative output, this positive output, this negative output, this positive, this negative, positive, negative. So this is the graph. One input is DC and other is AC. Okay, next is This is operational amplifier. Suppose one of the input is connected with the earth and there is a single input here, either AC or DC. There is output. So in this situation, the formula will be V out is equal to A naught Vn. So output voltage over input voltage is equal to A naught. But after this output, if some portion of the output voltage is added in the input voltage, mean fraction of output voltage is added in the input terminal, means some part of this output voltage is added back into the input terminal, then this procedure is called feedbacking, and the operational amplifier is called feedback OpAmp. So now we have to study the feedback OpAmp. What is meant by feedbacking and what is feedback? So when the fraction of the output voltage is added in the input terminal, then the procedure is called feedbacking. Now, the fraction, the portion of that output voltage is represented by beta V naught, 1/10, 100, 116, any fraction. So after feedbacking, new input will be V in the previous one and beta V naught after the feedback. So total becomes Vn plus beta V naught. So this is the new input now. So according to this rule, output is directly proportional to difference of the input. So output is equal to A naught difference of the input. So output is equal to A naught. So what is the difference? New input Vn beta V naught and the other one connected with the earth. So that is 0. So this is 0 potential. So this is the new formula after the feedbacking. Now output is equal to A naught V input plus A naught beta V naught, and this becomes 0. So we can rearrange it. This can be ignored. So output minus A naught beta output voltage is equal to A naught Vn. And left side, V output is common, which can be written as 1 minus A naught beta is equal to A naught Vn. And then we can write output over input voltage is A naught divided by 1 minus A naught beta. So look, when there is no feedback, this output over input, which is called gain, is simply A naught. It is represented by the A naught, but after feedbacking, the same fraction becomes more complicated. It's not alone A naught, it becomes A naught divided by 1 minus A naught beta. Now, beta is actually fraction of output voltage. So it can be positive, it can be negative, because sometime output positive, so it's fraction positive, sometimes output negative, so it's fraction negative. So here is the problem. So when V out is positive, it means this beta is also positive. So output divided by input, which is the gain, A naught divided by 1 minus positive beta A naught. Look, there's no change in the sign. It will remain A naught over 1 minus beta A naught. This is 1 unit, and this beta A naught product is subtracted from the 1. So the denominator is decreasing. So when negative feedback is given to OpAmp, negative beta, sorry, when positive feedback, sorry, not negative, positive. When positive feedback is given to the OpAmp, positive beta is added in the input terminal, the value of the denominator due to difference of these two terminal decreases. When denominator decreases, the whole fraction increases. It means with positive feedback, beta positive added in the input, output divided by input, which is the gain, it also increases. So the conclusion is, when the positive fraction of the output voltage is added in the input signal, it's a positive feedback. So as a result, this denominator decreases because this product is subtracted from 1. When denominator decreases, whole fraction increases, and fraction is gain. It means the gain increases. So this is called positive feedbacking, and the positive feedbacking increases the overall gain of the operational amplifier. So now we can define this positive feedback. Fraction of output voltage which is in phase with input voltage added in the input terminal then procedure is called positive feedback. So the fraction of the output voltage which is in phase with the input voltage and added in the input terminal, this procedure is called positive feedback. Okay, now suppose output from the operational amplifier is negative, then its fraction beta will also be negative. And this negative fraction of the output is added in the input terminal, then it is called negative feedback. Look, formula is output voltage over input voltage, A naught divided by 1 minus beta A naught, because this beta is negative in sign. So it becomes A naught divided by 1 plus beta A naught. Now in this situation, these two terms are added. So due to addition of 1 and beta A naught, this portion, denominator of the fraction, increases. So the whole fraction decreases, and the whole fraction is the gain. It means due to negative feedback, gain of OpAmp decreases. So due to the positive feedback, gain increases. And due to the negative feedback, gain decreases. Now the definition for the negative feedback, fraction of output voltage out of phase to input voltage added in the input terminal is called negative feedback. So the negative feedback fraction of the output voltage out of phase to the input voltage added in the input terminal is called negative feedback. But due to the negative feedback, gain of the operational amplifier decreases. But do remember, in electronics, negative feedback is preferred over positive feedback. Negative feedback is always preferred over positive feedback. Reason? Positive feedback will give you the quantity, not quality. Negative feedback, definitely less quantity, but high quality. So these are three major reasons for its preference. Number one, with the help of the negative feedback, we will get less distortion in output voltage. This is the number one advantage of the negative feedback. Less distortion in the output voltage. And the number two, bandwidth, mean the range of the frequency of input voltage increases. Bandwidth of the input voltage becomes more. And number three, operational stability of OpAmp increases, mean the life of the OpAmp increases. So these are the three major reasons due to which we reject the positive feedback and we prefer the negative feedback. So negative feedback gives the less distortion in the output signal. Bandwidth of the input signal, mean bandwidth the input voltage increases, and operational stability increases, mean compatibility increases, and it increases the life of the op amp.